So it is 12:55 p.m. and almost 13 degrees Celsius here in Kenya, which is extremely cold for this place. However, we are going to survive this. So, welcome to this tutorial where I am going to be teaching you how to make a 4-directional grid-based movement system using JavaScript and HTML canvas. And before we get to the tutorial, hopefully you like this video. You're going to press the like button and subscribe to this channel to help it grow. And if you have any questions and comments, feel free to leave them down in the comments. So let's get to the tutorial. Here I have a blank VS Code project, and what I'm going to do first is, of course, create my files. Let's have our canvas HTML, style, CSS, and main JavaScript file. And of course, these are the files that we're going to be working with. So what I'm going to do first is add my HTML template and link my CSS to it. Then I'll create a canvas element with an ID of canvas or any ID you'd like, and I will add my script element and then link my JavaScript file to the project. So what I'm going to do first is add the CSS, because we're going to only use this file once. And what I'll do here is select my HTML document and the body element and give them an overflow of hidden and a padding of 0 and a margin of 0. The overflow hidden will prevent the canvas from overflowing on the screen at times. It usually forms some scroll bars when you're working on other projects, and the padding will prevent it from having white space around the edges. So once we've done that, we'll select the body tag, give it a width of 100% and a height of 100%. Then we will change the background color to a slightly grayish color, because white is too white. It hurts the eyes. Then from here we'll align the canvas to the center by giving the body a display of flex, justify content center, and align items center. So now the canvas will be placed at the center of the screen. So next what we'll do is make the canvas fill the entire height of the screen and the entire width. Yeah, basically we'll make the canvas fill the entire screen. And now we are done with our CSS. We can just close the file. So next we will move to the JavaScript. And what we're going to do here first is select our canvas. I like to use document query selector because it looks cool, but you can use document get element by ID, or maybe get class, but I like to use document query select. So next we're going to take the context 2D of the canvas, which is like the pen that we're going to use to render everything on the screen. So this is, we have the pen and we've selected the canvas. So next we're going to make the number of pixels on the width of the canvas equal to the number of pixels on the screen's width, and we're also going to make the number of pixels on the height of the canvas equal to the number of pixels in the height of the window or of the screen. There's a difference between this and whatever we wrote in the CSS, which is that the one in the CSS just scales the canvas up, but this one actually tells the canvas you have this number of pixels on your width and this number of pixels on your height. You can look that up later in your own free time, but yeah, there's a difference between the two. So after telling the canvas that this is the number of pixels in your width and this is the number of pixels in your height, we will write the function to draw the grid cells. If you open the document right now in the browser, you will notice that nothing renders because we've done nothing at all so far. So what we're going to do is to draw the vertical and horizontal grid lines, and for that we'll create another constant. Let's call it cell size, which will be the size of the cells. And for now, I'll just make it 32 so that each grid cell is 32 by 32 pixels. 32 pixels long and 32 pixels wide. Then we will create a function and call it draw grid. And in this function, we'll use a for loop for let x is equal to 0, x is less than or equal to the canvas's width, x increment by cell size. So we're going to run the first for loop in this function as long as x is less than the width of the screen. And for each segment, which is cell size spaces long, I'll explain in a bit. We're going to take the pen and move it to the top of that position. Then we're going to draw a line to the bottom of that position. X canvas dot width. So for each segment, well, let's finish this and see the product first so I can explain. So after telling the pen where to go and what to draw, we won't see anything on the screen yet because we haven't actually told the pen to render anything. So for that, we'll use pen.stroke. It's a function that tells it, hey, you've already moved to these different places, now actually draw and show us what you've drawn. So now I'll call the function, and when we open the browser, you can see that we have our vertical lines. So this is because in this for loop, we are moving every time to, let's say for example, in the first iteration of the loop, we are moving to x is 0 and y is 0 over here. X is 0 and y is 0. Then we're drawing a line to x is 0, but y is the canvas width. So we are drawing a straight line from the top to the bottom. Then we shall move in the next iteration, the second iteration of the loop, we are going to move x is 32, y is 0. Then we're going to draw a line to x is 32 and y is 0. Then we're going to repeat the same process until x is less than or equal to the screen's width, and then we're going to do the same thing, move to that position and then draw a line to the bottom. So at this point, you can try to create the horizontal lines. It's basically nearly the same thing as the one for drawing the vertical lines. And yeah, I'll give you a few seconds to try this. You can pause the video and let's see if you'll be able to do it. So for those of you who are able to create the horizontal lines, good for you. But for those ones who aren't, we'll just write the code right now. So in order to create the horizontal lines, we are also going to use another for loop. For let y is equal to 0, y is less than or equal to the canvas's height. And then we'll increment y for every iteration by cell size so that each segment can be 32 pixels wide by 32 pixels long. Yeah. So in this iteration, what we're going to do is move the pen to x is 0 and y Then we'll draw a line to x. To x is the canvas width and y. So it's basically the same thing as the one we did before, but in this situation, instead of moving from y is 0 to y is the canvas height, we are moving from x is 0 to x is the canvas width. So now that we have the grid, we can now create the object that will be moving in our space. And for that, we'll create an object called constant, an object called maybe object position or character position or whatever you want to call it. And we'll give it an x property and a y property. Let's give it 0, 0 for now. Then we'll create another function called draw object. And for this function, we will use the pen fill rect method to fill a rectangle or to draw a rectangle at the object's position x and object's position y, and then we will give it a width, the rectangular width of cell size and a height of cell size. Then let's call this function and see what will be rendered on the screen. Yeah, you can now see that we have a rectangle at the origin position 0, 0 with a width of cell size and height of cell size. So now we can actually implement the movement code, and for that we will use an event listener, document.onKeyDown. This is what we call an arrow function in JavaScript, by the way. You can look it up, but it's basically just a function. So every time a key is pressed, we are going to run another function. Let's call it get direction. So every time a key is pressed, we are going to call get direction and pass in the argument e. And then in the get direction function, we are going to check if e.key is, let's say, w. Then what we're going to do is take the object's position y and subtract cell size, so that when the user presses w, we will take the y position of the object and subtract cell size from it. So we can also implement the movement code for the other sectors. Let's try right for now. For the other directions, I mean. Let's try right for now. And then for this, we are going to take the object's x position and add cell size to it. So now if we move to the browser, you'll see that when we press W or D, nothing's happening, and that's because we're actually not redrawing the object whenever we press anything. So we'll call draw object. And now you'll notice that we are moving, but the player is the object is sort of smearing itself on the screen, and when you press up or W, the player sort of moves out of the screen and you can't see them anymore. So we'll fix the smearing by create another function called update. And in this function, we will call the draw grid to redraw the grid. To redraw the grid and redraw the object at its new position. Then before we draw the grid and the object again, we will clear the entire screen so that there's nothing left on the screen. Then we will redraw the grid and the object. So every time we press a key to get the direction, we'll call the update function, which will clear the entire screen and redraw the grid, then redraw the object. So this will prevent the canvas from spilling. Oh, there's an issue here. We have it called update at the beginning so that we can actually see the grid before pressing any directions. So now we can see the player, and when you press D, we can see the player actually moving without smearing itself. So now that we can move the player without smearing itself, we can try implementing the other code for moving to other directions. So let's do that. So now we have the code for moving towards all 4 directions, and there's an issue here. Yes, I forgot S. Yes. So now when we press W, A, S, or D, we can see that we have an object that moves according to all the directions. So what I've done here is when you press D, the object's X coordinate gets cell size added onto it. When you press A, the X coordinate minused, so it moves left. And when we press S, the Y coordinate gets added onto, so we move downwards. So yeah, we basically have working 4-directional grid-based movement system. And now you'll notice that there are some other behaviors that when you pass through the screen, or when you go up, when you reach the edge of the screen, the player sort of disappears. You can maybe implement some behaviors that prevent that, or you can create another behavior that when the player passes from the top of the screen, they pop at the bottom. Or you can do anything you want with this. Then I'd like to see what sort of things you might make with this knowledge. You can maybe create a GitHub repo and leave the link down in the comments, and maybe in the future I might make a website where you guys display whatever projects you've made with the tutorials I'm going to be showing you. So now we have a moving character on a grid-based world, in a top-down maybe world if you want to make one. And yeah, I hope you liked the tutorial. If you have any questions or yeah, suggestions for videos I might do in future, please feel free to leave them down in the comments. And also, if you like it, like the video and subscribe to my channel and help it grow so you can boost my ratings on the algorithm. And yeah, thanks. Peace out.